All right, here we go. So this is section 11.3 in Algebra 2. And what I need you to do is just start by doing the warm-up. We're going to do it a little bit out of order. So start here, and then I'll come back and we'll talk about the vocab. Okay, so here's what you should have gotten. If you just do the math here, you of course subtract first and then divide by 1.5. You get 2.67. Same with here, do the subtraction first and then divide by 0.8. And here you should have gotten 0.95. And this says 68% of the sample of cars tested got between 27 and 32 miles per gallon of gasoline. What percent of cars tested got less than 27 or more than 32? So it's the remaining percentage, so it would be 100 minus 68, which is 32%. All right, let's go back up here and talk a little bit about what a normal distribution is and a normal curve. A normal distribution is a probability distribution with mean and standard deviation modeled by a bell-shaped curve, which is this right here. A normal curve is a smooth, symmetrical, bell-shaped curve that can model normal distributions and approximate some binomial distributions. All right, so basically the distribution is modeled on a curve, is shown on the curve. So normal distribution. Now we could be talking about in a factory, for example, if they need all these like nails to be 3 inches long. And they would probably create a normal curve to see if the nails fall within the most of the area right here instead of deviating too far, because that would be the assumption. I'm going to show you a couple other things here too. So here's a normal distribution represented with a normal curve. This is not in your notes. It's just kind of a sideline thing I just want to show you. You don't have to write anything down. It's sort of explaining what this distribution is. And in a normal curve, it shows right here the center, which is actually the halfway point, 50% this way and 50% this way. The center is the mean. Okay, so here I was talking about the heights of DHS students. I'm going to just assume that the average is about 65 inches, which is 5'5". And I'm going to represent a standard deviation of 2 inches. So in a normal curve, what it represents is, it says right here that this is the mean, 65 inches, and within a deviation of 2 each way, so that would be 63 inches here and 67 inches here, they're saying in a normal population, 68% of your population will fall in this area right here, within this range right here. And then if you go another deviation away, 61 inches this way and 69 inches this way, in a normal curve, this amount represents 95% of your population would fall between 61 inches and 69 inches. Okay, and then if you go even further, 2 inches more, the deviation, 59 inches, and this would be 71 inches. And this percentage here is 2.35% in that little area, 2.35%. So we can kind of assume that this is a total of 99.7% of the high school population will fall between, oh, this is supposed to be over here, sorry, will fall between 59 inches and 71 inches. And this is kind of where standard deviation comes into play. It's how far it is from the mean in a normal curve. So it's kind of interesting, based on normal data. Now, abnormal data would sort of be something like this. Like if we were comparing our GPA to the rest of the country, we could say in general the GPA of DHS students is an average of about 3.0. And so I'm going to say 1 is here, 2 is here, and 4 is here. So our curve is going to look more like this, which is not a normal curve. It's skewed. So that's the difference between a normal curve and a not a normal curve. We're just going to be looking at this today. All right? Now, standard normal distribution is normal distribution with mean of 0 and a standard deviation of 1. Exactly 1. Instead of here we had 2 inches, and we're going to see some other standard deviations. You're also going to be working with the z-score, which converts our x values to a standard normal table with a deviation of 1, telling us the number of deviations the x value that we're working with lies above or below the mean. It makes your data pretty much proportional to a standard normal table, which is what we're going to be working with back here. And here is the formula that you use to get a z-score. So let's just start right here with areas under a normal curve. I want you to draw some lines that go down to the 1 here and down to the 1 here. Now I want you to write down here that this is 34% and this is 34% under a standard normal curve. And then if we went over another deviation, this would be 13.5% and 13.5% this way if you went over another deviation. And then if we go over another deviation, this little tiny percentage here is 2.35%. Same over here, 2.35%. And remember when I showed you the students, this represents 99.7% of your normal data. Okay? So this last little tiny piece makes up for that little piece that's left. This is 0.15% and 0.15%. Remember the center is represented with the mean. That's the mean. And this, if you went over this way, would be your mean plus 1 standard deviation. And then if you were going over this far, it's your mean plus 2 standard deviations. And so on. Mean plus 3 standard deviations and mean plus 4 standard deviations. And it's likewise this way, except you're going in the negative direction. So this is going to be your mean minus 1 standard deviation. Don't be too confused by this right now. This is just like a general curve, and we're going to be working with numbers in a minute. This is the mean minus 2 standard deviation, mean minus 3 standard deviation, whatever your deviation happens to be. The first thing they're going to want you to do is just kind of investigate this curve and find out if you're in a certain spot, what percentage would be your data would land in that area. So a normal distribution has mean x and a standard deviation sigma. For a randomly selected x value from the distribution, find the probability that your data is going to land between your mean take away 1 deviation and your mean add 3 deviations. So you have to look at it. Here's your data piece right here. That's your x. And we're going to say this is where I'm going to start. Remember the P stands for probability. Again, the probability that this data value will land in this area or this area of the curve. So this is going to be your start, and this is going to be your finish here. So this is saying this area here, x, take away 1 standard deviation, and that happens to be 34%. That it lands in this area here, your mean take away 1. Then you got to add to it the percentage chance that it's going to land here in plus 1 deviation, then another deviation, plus another deviation. That's going to be your mean plus 3 deviations. So it's 34 plus this area, plus 13.5, plus 2.35. And you add those all up and you get 83.85%. Again, what this is saying is that if you choose a certain data point or value, the chance of it landing here all the way over to here, so take away 1 deviation all the way up to positive 3 deviations, is 83%, being in that area on the bell curve. All right, let's try one more. We have a data value right here, x. What's the probability that it will be your mean plus 2 standard deviations? So we're just going to go, okay, so let me say that again. What's the probability that your data value will be less than or equal to the mean plus 2 standard deviations? So we're looking at from this point all the way down. What's the probability that your data value will be somewhere here in the curve? So what you have to do is you have to add each of these up. Okay, so I'm going to start with this one right here. This is just less than the mean plus 2 standard deviations. It's 13.5. Then I'm going to add this piece right here, plus 34, plus another 34, plus 13.5, plus 2.35, and plus 0.15. And that totals up to a 97.5% chance, so that it's going to land from here all the way this way. Okay, so that's kind of like the first couple problems that you're going to have to do, really just adding up the different percentages from the normal curve. Okay, so let's look at this. The score of an exam for entrance to a firefighter program are normally distributed with a mean of 200 points and a standard deviation of 20 points. So if you kind of want to draw a little bell curve for yourself so you can just kind of visualize, if you need to, you may not need to, what exactly this might look like. So here your mean is 200, all right? And it says it's a deviation of 20 points. So it's going to be 20 points this way and 20 points this way. So this would be 180 and this would be 220. And remember, this is the 34%. And then the next little deviation will take you each to 13.5%, 13.5%. All right, let's see what we can do with this right now. It says, about what percent of the candidates score lower than 160 points? So I should have probably written 160 here. So what we're looking for is anything lower than this. So let's take a look at the other side and see what those two percentages are that are to the left of -2 standard deviations. It's 2.35 and 0.15. This would be the only possibility that they would score less than 160. So I'm going to add 2.35 and 0.15, and that's going to be a 2.5% chance that they would score less than 160 based on the normal curve. All right, so candidates with scores above 220 are admitted to the training program. About what percent of the candidates are accepted into the program? So we're looking at above 220, so we're looking for this direction here. Okay, so it's going to be 13.5%. That's just one standard deviation over and everything above. So let's look at what we have. One standard deviation over, everything above that, 13.5 plus 2.35 plus 0.15. And when I add those all up, I get 16%. So based on the normal curve, it's about a 16% chance that that many candidates would be in there. All right. So I found this kind of interesting. I just wanted to show you. This is the IQ. I don't know if you can see that. I'll make it a little bigger. I printed this off the internet, and this is the general IQ. Let me see if I can get a better picture. It's coming, it's coming. So again, this is the general IQ scores in the U.S., and average looks like to be right between here, about 100. And it's about a 15 deviation, you can tell by the table there. And this would be right here. It says the same thing. It's an average of 100. Again, it's a little dark. Sorry, I'm trying to get it right here. All right, that's a little better. And it looks like 68% of the population fall between an 85 IQ and 115 IQ. And then if we come all the way over here, there's not a lot that fall up here between 130 and 145. Maybe Jacob, Krista, maybe Lane. Oh, wait, maybe there's a lot of you that fall up here. Absolutely. All right. So I thought that was kind of interesting. You can find all sorts of stuff online about normal bell curve. All right, here. So I talked earlier about using a z-score. Let me zoom back out again. All right, a survey of 20 colleges found that the average credit card debt for seniors was $34.50. That's pretty depressing. The debt was normally distributed with a standard deviation of $11.75. Find the probability that the credit card debt of the seniors was at most $3,600. So we're going to use the standard norma table, and in order to do that, we have to find the z-score, because that's what all of these numbers are representing, the percentage when you look at the z-score, which is the distance from the mean that your data is. So what we're actually looking for is we're looking for the probability that the credit card scores are less than 3,600. Their credit card debt, is less than 3,600. And this standard normative table is what is using z-scores, which is what's on the outside here. So for example, here and here, right here, would be a negative 0.4 z-score, which would be 4 deviations to the left of mean. Here would be 3.5, which would be 3.5 deviations to the right of the mean. And that's kind of how that works. And that gives you the percentage chance of that happening. Okay, so let's calculate the z-score based on this equation right here. So I'm going to write that down. Z is equal to the data that I'm looking at minus the mean divided by the standard deviation. And they gave me all that information in here. Okay, so my z-score is my data, which is 3,600, data point, minus 3,450, divided by the standard deviation. And what that gives me is about 0.13. However, if you look at the table, the 3 doesn't really help me. What I need to use is just 0.1. And that's how many deviations from the mean 3,600 is in the bell curve here. So I look over here and I find 0 on the left side, which is right here. Since it's positive, it's this number. And I go over to 0.1, which is right here. Okay, that's the number I'm looking for. And what that number tells me, 0.5398, is that approximately 54% of college seniors have credit card debt less than $3,600, less than $3,600. If I would just draw a quick bell curve so you can see what I'm looking at here, I'm going to do that. I'm just going to draw a line, and I'm going to draw, kind of sketch a curve. This distance right here, this amount is 3,450. And they said there was a standard deviation of 1175, so this would be 4625 here. And 3,600 falls, I don't know, about right here. And they're saying that all of this is about 54%. So that's what you're actually finding. Okay? Kind of cool stuff, actually.